I welcome you all for today's session on Introduction to Automation. My name is Rajesh, Assistant Professor, Department of Mechanical, Global Academy of Technology, Bangalore. The topic which I am going to explain is Advanced Automation Functions, Levels of Automation, Automation Principles, Automation Strategies. As we all know that automated system is used for the executing work cycle programs, also may be capable of executing advanced functions, the functions that are concerned with enhancing the performance and safety of the equipment. The advanced automation functions include safety monitoring, error detection and recovery, maintenance and repair. Coming to the first point, safety monitoring. So when the automated process is going on with the use of sensors, tracking of the system's operation is done to identify the conditions that are unsafe. The safety monitoring does the following functions: initiate to completely stop a system, sounding an alarm, reducing the operating speed. So some of the sensors which are used in automated systems are limit switches to detect proper positioning of a part in a work holding device so that the processing cycle can begin. Photoelectric sensors to detect the presence of human or foreign body to trespass into the work cell. Temperature sensor to indicate that the metal work part is hot enough to proceed with the operation. Heat or smoke detectors to sense fire hazards. Error detection and recovery. Here, it uses the system's available sensors to determine when a deviation or malfunction has occurred by sending email error notifications. In production system, there are three different types of error that are encountered. First one is random errors. It is due to the stochastic nature of the process. Systematic error, which results from some assignable cause, such as change in raw material properties. Aberrations, deviations resulting from either equipment failure or human mistakes. So type of error recovery strategies has been followed by the level of urgencies. So first one is make adjustments at the end of the current work cycle, make adjustments during the current cycle, stop the process to invoke corrective actions if it is automatic action, stop the process and call for help if the automation is not able to fix, that is by following the manual action. So the maintenance and repair. There are three modes of operations which are used in cycle of maintenance and repair diagnostics. First one is status monitoring, which the current system status is displayed and serves two important functions: providing information for diagnosing a current failure and providing data to predict a future malfunction or failure. And failure diagnostics, which the diagnostics mode is invoked when a failure occurs. Recommendation of the repair procedure, where the system will suggest an adequate repair procedure to a team of experts. We know that the automation can be followed in different levels. The automations can be of simple types, complex type, of depending on the features and functions. So selection of automation and the level to which it has to be implemented to be properly selected. So there are different levels which I have been shown here in the figure. Here you come across five levels. The basic level here is device level. This is the lowest level in automation hierarchy. It includes the actuators, sensors, and other hardware components that comprise the machine level. So second level is of machine level. Hardware at the device level is assembled into individual machines. Example, CNC machine tools, automated guide vehicles, etc. In system level or cell level is called as also manufacturing systems. It operates under instructions from the plant level. The system is a group of machines or workstations connected and supported by a material handling system, computers, and other equipment appropriate to the manufacturing process. Next level is plant level, also called as production system. It receives instruction from the corporate information system and translate them into operational plans for production, where functions include order processing, process planning, inventory control, purchasing, material requirement planning, shop floor control, and quality control. Next, the last level, high level, is of enterprise level, which consists of the corporate information system. It is concerned with all of the functions necessary to manage the company functions like marketing and sales, accounting, design, research, aggregate planning, and master production planning. So, if any company want to go for automation, so it has to follow some basic principles and strategies. So when a company think of automation, So first it goes for following the automation principle. So that is USA. U stands for understanding the existing process. By reading the diagram or layout of process, that is flow chart, mathematical model, brainstorming, storyboarding, etc., you can understand the process in which the company is following. Next step is simplify the process, where it remove unnecessary steps and moves, eliminating combining and rearranging the process. And next one is A, automate the process by following. So it can follow 10 strategies for automation and production system, and also automation migration strategies. So we will learn one by one the 10 strategies of automation. The first automation strategy is specialization of operations. Here, the specialization of operation, it involves the use of special purpose equipment designed to perform one operation with the greatest possible efficiency, which is employed to improve productivity. Second one is combined operation. Here it is accomplished by performing more than one operation at a given machine, thereby reducing the number of separate machine needed. Let us say operation to perform is turning and milling. So using turn mill machine, both operations are performed in single machine. Thereby lead time is reduced for better customer service. Next, third strategy is simultaneous operation. It is an extension of combined operation strategies where two or more processing operations are being performed simultaneously. Example, in automobile, headlight and door can perform at single workstation simultaneously. And the fourth strategy is integration of operations, where it is linked with several workstations together into a single integrated mechanism by using automatic material handling system, where material will flow from one workstation to another, thereby increasing the overall output of the system. And the fifth strategy is online inspection. So inspection for quality of work. In traditional, it is performed after the process is completed. So incorporating inspection into the manufacturing process permits correction to the process as the product is being made. So that is, after completing individual operation, quality is checked. So this reduces scrap and brings overall quality of the product. And sixth strategy is process control and optimization. This includes wide range of control schemes intended to operate the individual process and associated equipment more efficiently. Seventh strategy which is being followed is increased flexibility. So while designing system, there should be allowance to handle variety of products by a process. So the prime objectives are to reduce setup time and programming time for the production machine. And the eighth strategies is improved material handling and storage. So layout for material handling and storage should be proper. If not, then the free movement of equipment and goods will be affected, resulting in poor equipment quality or productivity. So use of conveyor robots and automated guided vehicles will be used, thereby reducing work in process and lead time. So ninth strategy is plant operation control, where it is used for managing and controlling the equipment, facilities, systems in industrial and manufacturing process. Its implementation usually involves a high level of computer networking within the factory. And the last strategies is a computer integrated manufacturing. It is one level higher than the plant operation control uh, strategy, where it is integrates the factory operations with engineering design and business functions of the firm. Let us say in production we go for CNC machining, where computer systems are used for operating, and also in the quality department, coordinated measuring machines will be used in design, ProE, CATIA, all will be used, so that all the operations are integrated and uses computer applications, databases, network throughout the enterprise. So the 10 strategies constitute a checklist of the possibilities for improving the production system through automation or simplification. So before going to automation, one should follow the strategy of automation. If the product turns out to be successful and high future demand is anticipated, then it makes sense for the company to automate productions. So typically automation migration strategy is followed in each and every industries, which come under three phases: phase 1, phase 2 and phase 3. So the figure which I have been representing here indicates the phase 1 strategy, phase 2, phase 3. That is the migration strategy which the automation will be implemented. So due to competitive pressure in the marketplace, a company often needs to introduce a new product in the shortest possible time. The easiest and least expensive way to accomplish this objective is to design a manual production method using a sequence of workstation Operating independently, the tooling for a manual method can be fabricated quickly and at low cost. If the product turns out to be successful and high future demand is anticipated, then it makes sense for the company to automate production. The improvements are often carried out in phases. The phase one indicates the manual production using single station manned cell operating independently. Where you can see here the three workstations has been shown here, and here the working process will be going to take place. So all will be carried out manually. The purpose of following this manual operation is this is used for introduction of the new product quickly and with low cost tooling. The phase 2 using single station automated cells. So this is one station and this is another station and this is another station. So all stations are automated independently. As demands for the product grows and it becomes clear that automation can be justified, the single stations are automated to reduce labor and increase production rate. Here, work units are still moved between workstation manually. Here you can see here, the workstation in which the material handling or material manual handling will be carried out for each workstation. So next phase is using a multi-station automated system. You can see here all the uh, workstations are automated, and as well as the material transfer which takes place is also automated here. So when a company is certain that the product will be produced in mass quantities and for several years, the integration of the single station automated cell is warranted to further reduce labor and increase production rate. So it avoids the commitment to a high level of automation from the start, since there is always a risk that demand for the product will not justify it. So when we consider manufacturing, the manufacturing company can be of two types. One is discrete manufacturing and another one is process manufacturing. The discrete manufacturing, if the products manufacturing involve assembling components, then it is called as discrete manufacturing. Example, automobiles, cell phone and furnitures, where the resulting product are easily identifiable. And process manufacturing, if the manufacturing a product that requires formulas such as shampoo or pharmaceuticals, then it is a process manufacturer. The process manufacturing is common in food, beverages, chemical, pharmaceutical, consumer packed goods, and biotechnology industries. In process manufacturing, the relevant factors are ingredients and formulas. So the difference between the discrete manufacturing and process manufacturing is shown in this table, where in discrete manufacturing, the products are comprised of components that can be touched and counted, whereas in process manufacturing, the products are manufactured using formulas or recipes. In discrete manufacturing, the parts can be broken down and disposed of or recycled after productions, whereas in process manufacturing, products cannot be broken down back into raw materials. In discrete manufacturing, it uses bill of materials for its components or parts, whereas in process manufacturing industries, it uses formulas or recipes for preparing the product. In discrete manufacturing, assembles in a linear or routing way, whereas in process manufacturing, it goes with blends in batches. In discrete manufacturing, it involves joining, attaching, fixing, assembling, etc. Whereas in process manufacturing, it involves grinding, boiling, mixing, churning, etc. In discrete manufacturing, it does not involve change of volume or densities, whereas in process manufacturing, it involves change in volume, density, mass, physical properties. The example for discrete manufacturing is in automobile industry, the preparation of automobiles, cell phone manufacturing will come under discrete manufacturing. In process manufacturing, example is food, beverages, industries, etc. So one of the video which I'm going to show here, which clearly indicates the discrete manufacturing and process manufacturing. So this shows the difference between process industries and discrete industries. So any industry which go for controlling the system. So there are two types of control which is being followed. One is continuous control and discrete control. The process industries follows the continuous control where the mechanisms that uses continuous monitoring of an industrial process operational variables, example temperature, pressure, chemical content and algorithms, and then uses the information to adjust variable to reach product output specifications and objectives. Whereas in discrete control, the mechanism that uses discrete monitoring of an industrial process, operational variables like position, velocity, acceleration, force, etc. So it is like switching on or off of a variable when required to get the desired output. So thank you. Today, what we discussed is based upon the process manufacturing and discrete manufacturing, the difference between each of them, and also we discussed about the principles and strategies of an automation. Right. So all this will be implemented based upon the automation level which will be implemented in the industries. And also we discussed about 5 levels of automations, and also um, we discussed about the functions of an automation. Right. So thank you very much.